don't need. All right, doc to process. Okay, so we removed numeric digits. That's one of the first steps in here. So this is for I in range 0 to 1867. So it looks like we have 18,687 documents, which is, it sounds like a lot, but I mean, you need that many iterations. You need that many records if you're going to do deep learning. You know, like a minimum of 10,000, like 20,000 is great. For deep learning, you just need a lot of stuff to train on if you want it to be effective. Okay, so remove numeric digits. I took a look at the data set, and books have a lot of these books have a lot of numbers in them. They have a lot of statistics and graphs, which is cool, but I mean it's not useful for what we're doing. Like I said, we're looking at which category a document fits into, and the numbers in graphs on there don't particularly matter too much because we're looking at the words. Okay, remove punctuation and make lowercase. So for a computer, an uppercase L is a completely different thing from a lowercase l. Like we as humans see them as kind of the same thing. You can have an uppercase L or a lowercase l. Actually, like, let me show you. We can have a lowercase l or an uppercase L, and neither one of those really, it doesn't matter which one you choose. To us, but a computer like sees those as completely different things. And so if you make everything lowercase, it makes it easier for the computer to understand. Also, punctuation doesn't really matter in this case. It matters to us if we want to understand what the words say, but if we're trying to figure out what category it fits into, that doesn't really matter. Like, think about it. If you are, let's say you have a book in front of you and you're trying to figure out what the topic of the book is. You just scan it, you just look for keywords. You don't look at the punctuation or the question marks. All right, so remove stop words. Okay, print normal. Okay, so normalized text. What that means is you sort of, you get rid of things that might confuse the machine. Normalized means different things in different contexts. Like in numerical data, normalization means scaling it so that it's all sort of closer together within a range of like -1 to 1. But normalized text means you have prepared it. You prepared it all in the same way for this data processing. Okay, dot print da 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 da. So here's something to note. So we set full train data as a pandas data frame, and what this loop does is it circles over and over again from 0 to 18687, and each line, one by one, it does all of this stuff to that one line, right? And then it puts it back in place. I think. Let me see. Oh no, it doesn't put it back in place. It puts it into a new document called documents processed. It puts it into a new pandas data frame. So what it does is it looks at the original one, full train data, and then it takes one line, see at I, and then it removes the digits, removes punctuation, blah, 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 and then it puts that one into a new place called doc processed. It does that one line by one line. So after we have done that, after we've created the full train data full train data pandas data frame, we do dot head, and that will show the first number of rows. So it's not going to show all 18,000 rows. It's going to show like maybe, I think like 10 to 50. I don't exactly remember how many rows. Okay, so full train data. So at this point, what I did is I exported it to CSV, comma separated value, which is a file that you can save on your computer and show in Excel. I did that because I wanted to save all the progress that I had made. Because like sometimes when you exit out, you lose all your progress and you have to do it all over again. And just to let you know, this was probably the longest part. Training the model didn't take nearly as long as performing all of the operations on 18,000 thingies. This took me, I think this took like 3 hours to complete maybe. So when it was done, I was like, I'm definitely saving this to CSV. I don't ever want to have to do that again. Okay, so train value, train display, blah, blah, blah. Okay. Okay, so we talked about training and testing, or splitting a data set into training and testing, or people call it training and validation. Either way is fine. I guess that's less confusing because they don't both start with a T. So after we processed all of the data, we split it into training and testing. Actually, I have a machine learning wrap that I wrote. It says split your cleaned up data into training and test. So that's what this is. Train.head, as we talked about, the .head command used on a pandas data frame shows the first number of rows. Val.head validation data set shows the first number of rows. You want to do that every time you transform a pandas data frame because you just want to take a look at it and make sure there are no empty columns, make sure you didn't mess it up, make sure it didn't get scrambled. It's just a good policy to follow. All right. Okay. There we go. That's the tokenizer. So after we split it, we do the tokenizer, vocabulary list, data bunch. Oh, here we go. So this is really important. These are the label columns. These are the columns from your data. So like we talked about, we talked about the documents fit into different categories. Information and communication technologies is one of them. Governance, urban development, law and development, public sector development, agriculture, communities and human settlements, whatever. So these are all of the categories that your documents fit into. So, and they're also going to be what you have to guess. Like if you're given a book, if you're given a document, you have to guess which of these categories it fits into. Okay, so let's see, path equals input. Like I said, this is for locating your data sets. Data bunch, show batch. Let's see, BERT model. Okay, so this is where we pull in the BERT model, which is that pre-trained model that we talked about, which basically it's just trained on a lot of text and it's really good at handling text now. So okay, so loss function determines how your model trains itself. Like when you're training your artificial intelligence, what you do is you have your inputs and your outputs, and it adjusts itself so that your inputs match your outputs. And loss function helps you do that. Let's see. Okay. All right, we're not going to go into that just right now. All right, accuracy. So it looks like we're using accuracy as a measurement. BERT equals model class. Create learner function. Okay. Okay, so I don't even know what any of this is. I just came here and it was like this. So. So the original repository, what it actually did is it classified between positive and negative tweets is what it did. And so I modified it. So instead of just having 2 classes, positive and negative, I made it so it has 24 classes: information and communications, governance, etc. Actually, I think this data set might have come with even more than 18,000 entries. What I did is I made sure that each class has an equal number of records in it. And that's really important because if you train a class with like way more records than the other class, then your accuracy becomes worthless. Let's see, loss function, there we go. I know I didn't give a satisfactory explanation for what a loss function is. You can look that up online or I can explain later. Let's see, function. BERT class, split model. Okay, so I suppose they split the model because it's too big. Learner, learner save, load head. Oh, okay, so this is really cool. So this is called transfer learning. So a machine learning model, like especially a deep neural network, has a bunch of layers. They can have tons of layers. So what you do is you unfreeze the last few layers of the model and you train it again. So I did this with my cat one time. There is a model, I forget what it's called, Fast.ai or something like that. So anyways, it's trained on thousands of images and it's got maybe like 100 different classes, and I wanted to retrain it so that it would recognize only my cat. So instead of retraining only my cat from the start, like my own model from scratch on 20,000 images of my cat, I can take this pre-trained model and I can just retrain the last few layers on images of my cat. And I can only work with like maybe 200 images. Let me see. All network layers. Okay. So let's try this. Okay, so here's a good image. Okay, here's the final neural network layer. So what I would do is I would just retrain this one so that it can detect my cat. And so that's what we're doing with this one. So we already talked about how BERT is really, really cool, and it can, process text really, really well, but it isn't designed specifically for our application, which is classifying documents. So we are going to unfreeze the last two layers, and we are going to train those last two layers using our data set, using our documents. We're going to say, okay, last two layers, this is the document, this is the input, and then we want you to know that this document is classified as an environmental document. Okay, so learn that save, learn that load. Jump cut. Okay, so I wanted to make it really, really clear that the reason why we are taking BERT as our model is because BERT is really, really good with words. It was trained to be really, really good with words. So we've got this amazing model, super good with words. We saw it on Text to Transformer or TalkToTransformer.com. It's amazing with words. We are just going to train the last two layers to work with our data set. It's kind of like taking a Jeep that's awesome, and then you put on the front of it like a tool that you need, like a winch or something for your particular purpose. Like you need a Jeep to pull your other car out of the mud, so you just take a Jeep and then you add a winch on it to your particular purpose. And just like that, we're using an awesome model called BERT, and then we're adding a little thing on the front of it to make it so that it can classify the documents that we need it to classify. So what's really funny is like the pre-processing code, back up here, it's like enormous. There's so much code to pre-process this data to make it so that the machine can understand it, and then the data for just actually training the thing, this is it. Like this is it right there. Like it's saying, I think this says 2 layers, is training the last 2 layers, etc. It's giving you like some hyperparameters. But so, like I said, there's so much work that goes into pre-processing it, and then actually using the model, and then like unfreezing it, and then training the last 2 layers is simple. It's one line of code. Look at that. So look, we freeze the last 2 layers of the model, and we train again. See, we unfreeze them, and then we train the last 2 layers. So, and then we save, and we load the model. Okay, unfreeze the entire model and train it. So see your model's predicting power. Okay, so it looks like right here, what we do is we are testing the model to see if it predicts well. And like learner.predict. So from what I remember, this one behaved really, really well. It was like some kind of high accuracy. I think it was like 70, probably like high 80s, like 89 or something like that. So we don't stop there though. When we have our trained model trained on our data set, we're excited about that. But what Kaggle does is it gives us a second data set. Like the first data set that it gave us was questions and answers, right? And so we trained our neural network, aka our very intelligent child, using those questions and answers. And we withheld some of the answers so that we could test him, right? So Kaggle gives us this entirely new data set that is all questions and no answers. So, okay, so like imagine you have a genius child, right? And you don't want to learn math. So you want this kid to help you cheat on your exam. So you have an exam coming on Friday, and it's a huge math exam, right? So you want to train this genius kid to take your math exam for you. So what you do is you have 100 questions and answers from your math textbook, and you give this genius kid 70 of those questions and the answers, so he can learn how to solve those questions on his own. You don't want to just send him into the test without knowing if he can actually do it. So how you test him, you test him yourself first. So you quiz him using those 30 questions that you withheld from him, right? And as a side note, it's important to randomize those questions because you don't want to train him on the first 70 easiest questions and then withhold the last 30 hard questions. You want to randomize it all so he has equal likelihood of getting a hard question or an easy question on all the topics. So then you tested him and he is getting a 99% accuracy on the test questions, right? So then you say, okay, I'm going to try, like my kid is really smart now, so I'm going to try sending him into my final exam. So Kaggle is the one who gives you that final exam. They give you a bunch of questions with no answers yet, and then you use your intelligent child or your neural network to answer those questions for them. And Kaggle has the answers, but they haven't shared them with you. So they will say, okay, you got a 99% on this test, or you got a 50%, and they will let you know if your neural network, aka your intelligent child, performed well or performed poorly. So, all right, so what we do is, I believe, yeah, test doc. That's what this is. Test doc is the data set that Kaggle gave to me with only the questions and no answers. And again, like actually using the machine learning model is really, really easy. See, you just do learner.predict. That is one line of code to send that whole thing into the neural network's brain. So then after I did that, all I did was, let's see all this, I just sent it to CSV, test values.to.csv, and then it outputs a .csv file, which is again an Excel file, and then you upload that to Kaggle as your answer database, or as your answer data set, and they have a particular format that they want you to put it in. So pay careful attention to that, but after you upload that, Kaggle will give you a grade and see how well you performed. And if you performed well, then you can be really excited. If you got like even like a 50%, if you got even like a 70%, you can be really excited because you can say, I did this. I used machine learning to solve a real world problem. I have enough of a grasp on machine learning that I can apply it to the real world. Like, there's a big difference between learning principles, which are really cool, and being actually able to apply them to a real world problem. And it gives you a lot of confidence because you can tie many, many principles together. Like we talked about data pre-processing at the beginning and all the things that you need to do on text specifically. And then we talked about training a neural network or importing a pre-trained neural network and only training the last 2 layers, which is called transfer learning. So just knowing that you can string all of those concepts together in one script that can accomplish something is just a really cool confidence booster. So I hope that was helpful. If you guys have any questions, feel free to message me directly or leave questions in the comments or join the Slack group. I would recommend joining the Slack group and posting your questions publicly because then other people can learn from the answers too.